Hello, and welcome to Summarize Science. Have you ever wondered about the dramatic final moments of the biggest stars in the universe? These stellar titans, known as red supergiants, live fast and die young, ending their lives in spectacular supernova explosions. But the lead-up to that explosion is filled with cosmic drama, as we saw with the famous star Betelgeuse a few years ago. A new paper investigates this very process, focusing on one of the biggest puzzles. How do these giant stars lose so much of their mass before they explode? Is it a slow, steady wind, or do they violently throw off huge chunks of themselves in episodic bursts? To find out, a team of astronomers conducted a detailed investigation of 7 specific red supergiants in 3 nearby galaxies. These weren't just any stars, they were chosen because they are particularly dusty, a sign that they might be very active in shedding their outer layers. By tracking their brightness over many years, the researchers created what are called light curves to watch for any unusual behavior. And they found some truly wild activity. Take a look at this star, named NGC 6822-52. Its light curve shows that its brightness varied by an incredible 2.5 magnitudes, which means it was flickering by about a factor of 10. This is an unusually strong pulsation, suggesting the star is highly unstable. The researchers also found that its surface temperature has changed significantly over the last few decades, a bit like a stellar identity crisis. But the most exciting discovery came from a different star, NGC 6822-175. This star experienced its own great dimming event, very similar to the one that made Betelgeuse famous. Here, the researchers have plotted the dimming of their star and overlaid the data from Betelgeuse for comparison. The event lasted for roughly 550 days, during which the star faded significantly as it likely ejected a huge cloud of dust that temporarily blocked its light from our view. This is a smoking gun for an episodic mass loss event. It's direct evidence that these stars can and do have violent, short-lived outbursts that contribute to how they evolve. The team also noticed that some of the other stars they studied showed signs of past outbursts, like having a different temperature than expected for such a dusty star. This suggests the star was cooler and puffier in the past, lost a lot of mass, and has since heated back up. So, what does this all mean? The study provides powerful evidence that for many red supergiants, the end of their life isn't a gentle fading, but a series of dramatic outbursts. Out of the 7 stars studied, 4 were identified as strong candidates for having undergone this kind of episodic mass loss. This tells us that Betelgeuse's great dimming wasn't a freak event, but likely a normal, though rare, part of a massive star's life cycle. For the future, this work highlights how important it is to continuously monitor these stars. Upcoming projects like the Rubin Observatory will scan the entire sky repeatedly, allowing astronomers to catch many more of these dimming events in the act. This will help us finally understand the mechanisms that drive these stars to their explosive ends.